Hi everybody, welcome to another section in Math 1324, section 4.5 and section 4.6. I put these two sections together because they related. So first we studied inverse of the matrix. Before we define an inverse matrix, we will define an identity matrix. Identity matrix is a square matrix. By square, we mean the same number of rows as the column. So number of rows equal to number of columns. And identity matrix is a square matrix. And the way we define that is identity matrix I, then any matrix of the same order, order. A times I the same as I times A is the same as A. So in terms of numbers, it looks like number 1. So 1 times x is the same as x times 1 is equal to x. So the identity matrix is acting as number 1. So in general, the identity matrix is the matrix we have 1 on the diagonal. The diagonal here will be northwest, southeast diagonal, and 0 everywhere else. So like this is the matrix, identity matrix of order 1, of order 2, sorry. Identity matrix of order 3 will look like this. So we have 1 on the diagonal, 0 everywhere else. And after we define the identity matrix, we can define the inverse of the matrix. So if there's the matrix A of square matrix, the inverse, if it says, is that A times A inverse is equal to identity, or A inverse times A is equal to identity. So if the product is equal to identity, either way, I mean both ways, this is n, so we have to have both direction. If that is the case, then that they are inverse of each other. And so in terms of the numbers, it look like this. 1/2 is the inverse of 2 because the product is equal to the identity element, and because we have 2 times 1/2 is equal to 1. Right, so the way we define inverse is that the product of the matrix and the inverse equal to identity, and the inverse and the matrix have to be, we have to require to have both of them. So we have -1. First we're going to check to see if the A times B is equal to identity, and then we check B times A, is that equal to identity. We need to check both of them. If both of these boxes are checked, then they are inverse of each other. And then B. So let's take row times column. -1 times 5 is 5, -5 plus 6, so it's 1. Row times column, -3 plus 3, -10 minus 10, and 6 minus 5 is 1. So this is the identity matrix. We have 1 on the diagonal, 0 everywhere else. So this is equal to identity matrix. So we check that. And now we take B times 8. So that's B times A. Right, row time column. So that gives us -5 plus 6, so it's 1. 15 minus 15, 0. -2 plus 2, 0. 6 minus 5 is 1. So this is identity matrix. So we check. So the product A times B equal to identity and B times A equal to identity. So we have both of them. So we say A and B are inverse of each other. Now find the inverse of a 2 by 2 matrix. Now there's a formula for inverse of a 2 by 2 matrix. So if we have the matrix A like that, what we do is we will swap these two. Swap places. So to see the D go up and A goes down. And then these two, we change the sign. So change the sign. So these two swap places. These two change their signs. So negative, negative. And then we have to divide by 1 over AD minus BC. And AD minus BC have to be not equal to 0. Because if that equal to 0, we divide by 0 and that undefined. So if AD minus BC is not equal to 0, we have the inverse of a 2 by 2 matrix. Let's use that formula to find the inverse of a 2 by 2 matrix. So we have that. So first thing, the inverse. It's going to be 1 over AD minus BC. Then over, now we swap places here. 1 and 5 interchange the places. And 2 and 4 interchange the sign. So that gives us 1 over 5 minus 8 minus 3. Then we have 5, -2, -4, and 1. So multiply that in. We have -5 over 3. Multiply that 2/3. That in, so that be 4 over 3. And that will be -1 over 3. Right. By the way, if we want to find the inverse, we put the matrix in this form, a matrix matrix A and then I, identity, and then do the reduce to echelon form. We have that. Now, if it is 3 by 3 or higher, we should do that. But let's just test and see if it works. So we have reduce to echelon form. We're going to put the identity A and then identity. So if we put A here and then next to it identity. So this example we will have this and then identity here. So I will have this. I don't recommend doing. If you have a calculator, just find the inverse directly. Right, so we have 1, 2, 4, and 5. And then on this side we put the identity matrix. And then we convert to fraction. and you see we have the inverse here. But the best way to find the inverse, of course, just if you have a calculator, just have the matrix. Inverse. And inverse is that button. So that's more direct. Of course, but in real life, finding this is a lot more efficient than find inverse some other way. But regardless, if you have a calculator, I recommend just enter the matrix and hit the inverse button. Right here. Let's find the inverse of this. Even though you can use this, but I recommend just use the inverse. Alpha zoom 3 by 3. Okay. 1, -1, 3, 2, 1, 2, -2, -2, and 1. Okay, so we have that matrix and then the inverse button. That's pretty much it. Of course, we convert this to fraction, and that's pretty much the inverse of the matrix. So it's very simple. Like I said, it's simple too if we have a calculator, but in real life, if we have to find 3 by 3, that would be very complicated. Right, and for 3 by 3 or higher, I will not require you to do this by hand. So for 3 by 3 or higher, we use calculator. For 2 by 2, we can use this formula. Right. Now we have one application. So this application we call the cryptography. So we can use this simple coding. So in this case, we assign 1 to 26 as the letter. So A is 1, B 2, C 3, D 4, E F G H I J K L M N O and so forth. And we let the space to be 0. Right, so that's what we have. Now to decode, what we do is we're gonna write this as with the numbers, and then we will stack that as the right. So first, if we let the message secret code, and then we choose that A this matrix as the encoding matrix. So first we have to write secret code as a number values. So I hate it when we have to flip the page. I shall have secret code. So secret space code. S 19. Now we convert these two numbers to 19. E C D no R 18 E T space 0 code C 15 4 5. So let the message be that and the matrix will be 4 3 1 and 1. Right. So we have the list of numbers here. So convert the message to numerical values and stack it in the B of the 2 by n. Right, so we're going to stack these numbers into the matrix. However, if we stack the matrix of the 2 by n, we don't know how long we go before we break that into 2 by n, because the matrix A, the coding matrix, is 4 3 1 and 1. So we have to have the message have to be something like 2 by n. So in that case, we don't know how far it goes on the row. So in that case, what we have this, we're going to stack that in column. So the message, we're going to write this in column because we don't know how far we go horizontally. So we just go 19, 5, 3, 18, 5, 20, and 0. So 3, 15, 4, and 5. We just complete this, we just have to write 0. So that. So this is the actually the matrix B. Right. Now to decode it, we take compute M is equal to A times B, and that is the encoded message. So we have construct M is equal to AB. So A is 4311 and B 19 3 5 0 15 5 5 18 20 3 4 and 0. Now we just multiply them. Nineteen 3 5 0 15 and 5 5 18 20 3 4 and 0. Right, so we have that 91 66 80 9 72 and 20 24 21 25 3 19 and 5. So that. So we're going to make this public. Actually, we're not going to do this. We're just going to give public this list of number. And we just write that in column, and we'll make this list public because people in the public, if they don't have the inverse, they won't be able to decode this. So in that case, so only the person that have the inverse, they can find, can decode this. So first we find inverse. If A is equal to 4311, and the A inverse. So if that. So if this inverse, now this will be decode the matrix. So what we do is we take A inverse times M. So 1, -3, -1, and 4, and multiply this. Right. And now we will okay. I'm just going to highlight this, so that is the inverse, and then okay, sorry. I guess we have to just enter it manually. (91, 66, 80, 9, 72, 20, 24, 21, 25, 3, 19, and 5. Alright, so when we do that, as you see, we'll recover the message. And of course from here we can just write that again, and that of course will be the secret code. So that is decoding and encoding. In short, what we have is we take the matrix, multiply by the message, make that public. Only the person with the matrix or only person with the inverse can decode that, multiply it back to get back to the message. Right, now this is another application which is more important. So in this case, we call the matrix equation. So first we can, if we let the matrix the equation into the matrix form of Ax equal to B. And now we're going to solve for x. Of course, if we just go ahead and divide by A on both sides, then we have x. However, we cannot divide matrix like that. So what we have to do is multiply by the inverse. So I multiply the inverse on both sides. And I multiply in front on both sides. A times A inverse. It will be I. So I times X is equal to A inverse B. And identity times anything, or anything times identity is itself. So X equal to A inverse B. So rather than divide by A, we multiply by the inverse. So that's what we have. Now go to the solution. So now I will set up the matrix equation. So first we just find the matrix. Let A be the matrix of all of the coefficient 1, 2, 4, and 5. Then we let X be the matrix of variable X and Y. And then B is the matrix of 3 and 6. So in that case we have A times X is equal to B, and with that we have X equal to A inverse times B. So we have the inverse of 1, 2, 4, 5 inverse times 3 and 6, and we know how to find inverse of 2 by 2, right? 1 times 5. I think we find the inverse of it earlier. Yeah, would be this. But let's do that again. 1 times 5 minus 2 times 4. Forget that. And now this, swap into places. 5, 1. Changing the sign. -2, -4. And then multiply by 3 and 6. And then we take the inverse, multiply by that. So here, if I have the calculator already, I'm just going to say I have the matrix. And multiply by 3 and 6. -1 and 2. So that's what we have. So we have the coefficient matrix A, X the matrix of variable, and then B is the constant on the other side. With that we have AX equal to B, and so that case X is equal to A inverse times B. Right, now let's use that again for this. This is 3 equation with 3 variable. Definitely we're going to use the calculator here. So the matrix A, 1, 1 and 2, 2, 1 and 0, 1, 2 and 2. The matrix X, X, Y and Z. And then 1, 2, 3, we will make that matrix B. With that we have AX equal to B, and X is equal to A inverse times B. So we just have the inverse. Times B. By the way, I'm gonna put the link to find the inverse in the description, so you don't have to do that by yourself, but you still need to multiply, take the inverse, and then multiply this yourself. Find the inverse first, and then multiply that. inverse. So after that, if we have the inverse, and now we can pretty much take this result and then we multiply by 1, 2, 3. Or here, if we're just going to say we have that, now we just multiply by the inverse. The inverse we multiply by the matrix. So we have that. Now let's look at this application. Labor and material cost for manufacturing two guitar A and B given by this. Suppose that in a week we have 1800 is used for labor and 1200 for material. How many of each should be produced? So we have total labor cost is 1800. So in that case we have 30A plus 40B. So 30 for each guitar A and 40 for each guitar B add up to 1800. Then we have 20 of guitar A plus 30 of guitar B is equal to 1200. How many of each model should be produced? So you have system equation, that's easy. Alright, so in that case, we just have the matrix and then multiply by x A and B equal to 1800 and 1200. So this is like AX equal to B. Of course the A here and the B here just make it different. One face A, one face B. Now just solve for X. So in this case X is equal to A inverse B. Times B. So if you don't have a TI calculator, you can use the link in the description of the video. $60 and 0. Right, so that's what we have. Right. So with that, we finished section 4.5 and 4.6. Actually, we finished chapter 4 in Math 1324. As always, thank you for watching and see you in another video of Math 1324.